Welcome to this exploration of one of the most transformative inventions in human history, the steam engine. I'm fascinated by how this seemingly simple concept of harnessing the power of steam revolutionized industry, transport, and society as a whole. The steam engine was not just a technological marvel, it was the beating heart of the Industrial Revolution, fundamentally altering the course of human progress. Now you might be wondering, what exactly is a steam engine? At its core, it's a machine that converts the heat energy of steam into mechanical energy. This process might sound straightforward, but its implications were far-reaching. The ability to generate power without relying on human or animal muscle, wind or water flow was nothing short of revolutionary. It's quite remarkable to think that this technology, which seems almost quaint to us now, was once at the cutting edge of human innovation. The story of the steam engine is not just one of technical innovation, but of human ingenuity and perseverance. It's a tale that spans centuries, from the earliest experiments with steam power to the complex machines that drove the industrial age. Throughout this video, we'll explore the evolution of the steam engine, its key inventors, and the profound impact it had on the world. We'll delve into the mechanics of how these engines work, the challenges faced in their development, and the legacy they've left behind. So let's embark on this journey through time and technology, and discover how the power of steam changed the world. The adoption of the steam engine and the birth of the Industrial Revolution is a complex story of scientific, technological, and social change. The concept of harnessing steam power dates back much further than many might expect. In fact, the earliest known rudimentary steam engine was the aeolipile, described by Hero of Alexandria, a Greek mathematician and engineer in the 1st century AD. This device, while fascinating, was more of a curiosity than a practical application of steam power. It consisted of a hollow sphere mounted on a stand, which would spin when water was boiled inside it, forcing steam out through two bent tubes on opposite sides. It's quite remarkable to think that nearly 2 millennia passed before steam power began to be seriously explored for practical applications. The intervening centuries saw sporadic experiments and designs, but it wasn't until the late 17th and early 18th centuries that we see the true birth of the steam engine as we know it. This delay in development is a testament to the complexity of harnessing steam power effectively, as well as the specific economic and social conditions required to drive such innovation. The steam engine did not burst suddenly upon the world. It was the product of a long period of scientific investigation into the properties of steam and the development of suitable materials and techniques of manufacture. The first commercially successful steam-powered device was a water pump, developed by Thomas Savery in 1698. Savery's engine was designed to pump water out of coal mines, a critical problem of the time as deeper mines were constantly flooding. His pump used the power of vacuum created by condensing steam to draw water up from the mines. While innovative, Savery's engine had significant limitations. It could only raise water by a limited height, and was prone to boiler explosions due to the high pressures involved. Despite these drawbacks, it represented a crucial step forward in the practical application of steam power. The next major development in steam engine technology came with Thomas Newcomen's atmospheric engine in 1712. Newcomen's design was a significant improvement over Savery's, addressing many of its predecessors' limitations. The Newcomen engine used a piston within a cylinder, a design that would become fundamental to steam engines for centuries to come. This engine operated on the principle of creating a partial vacuum by condensing steam under a piston within a cylinder. Newcomen's engine was primarily used for pumping water out of mines, much like Savery's, but it could work at greater depths and was significantly safer. The engine's operation was ingenious. Steam was introduced into the cylinder, then cold water was sprayed in, causing the steam to condense and create a vacuum. Atmospheric pressure would then push the piston down, providing the power stroke. The engine's efficiency was low by modern standards, but it was a vast improvement over what had come before. Newcomen's engine, imperfect though it was the first really successful device for converting heat into work, and as such must be accounted one of the greatest inventions of all time. The Newcomen engine saw widespread adoption, particularly in the mining industry. Its impact was significant, allowing for deeper mines and increased coal production, which in turn fueled further industrial development. However, its high fuel consumption and the limitation of only being able to provide reciprocating motion meant there was still room for improvement. Despite these limitations, the Newcomen engine remained in use for much of the 18th century, with hundreds built across Europe and North America. Its success laid the groundwork for the next wave of innovation in steam power, setting the stage for James Watt's revolutionary improvements. The next major leap in steam engine technology came with the work of James Watt in the latter half of the 18th century. Watt's improvements to the Newcomen engine were so significant that he is often credited as the inventor of the modern steam engine. His key innovation was the addition of a separate condenser, which addressed one of the main inefficiencies of the Newcomen design. In Newcomen's engine, the cylinder was alternately heated and cooled with each stroke, wasting a great deal of energy. Watt's separate condenser allowed the cylinder to remain hot while the steam was condensed in a separate chamber. This seemingly simple change had a profound impact on the engine's efficiency. Watt's design used about 75% less fuel than a similar-sized Newcomen engine. But Watt didn't stop there. He continued to refine and improve his design, introducing the centrifugal governor for automatic speed control, the steam indicator for measuring steam pressure, and the parallel motion mechanism for converting reciprocating motion to rotary motion. These innovations made the steam engine more efficient, more controllable, and more versatile. Watt's steam engine was the fundamental technology of the Industrial Revolution. It gave us the notion of horsepower and brought the concept of energy to the forefront of science. The impact of Watt's improved steam engine was immense. It was no longer confined to pumping water from mines. It could now power a wide variety of machinery. This versatility led to its adoption across numerous industries, from textiles to manufacturing, dramatically increasing productivity and driving the rapid industrialization of the late 18th and early 19th centuries. Watt's steam engine became the powerhouse of the Industrial Revolution, transforming not just industry, but society as a whole. It's fascinating to consider how this one invention, born from the continuous refinement of earlier ideas, could have such a profound and lasting impact on the course of human history. As we move into the 19th century, we see the steam engine evolve and diversify, finding new applications that would reshape the world. One of the most iconic and transformative of these was the steam locomotive. The development of steam-powered transportation began in the early 1800s, with pioneers like Richard Trevithick and George Stephenson leading the way. Stephenson's Locomotion No. 1, built in 1825 for the Stockton and Darlington Railway, is often considered the first steam locomotive used on a public rail line. The impact of steam locomotives on society was profound. They revolutionized transportation, allowing for the rapid movement of goods and people over long distances. This had far-reaching effects on trade, urbanization, and even the concept of time itself, as railway timetables necessitated the standardization of time across regions. The railway mania of the 1840s in Britain saw a massive expansion of the rail network, fundamentally altering the landscape and economy of the nation. It's quite remarkable to think how quickly this technology spread and how deeply it became embedded in society. The steam engine, in all its applications, remains the most extraordinary invention in the history of technology. It was the steam engine that made the Industrial Revolution possible, and it was the Industrial Revolution that brought about the world we live in today. But railways were just one aspect of the steam age. Steam engines found their way onto roads with steam-powered automobiles, into factories powering all manner of machinery, and onto the seas with the development of steamships. The first commercially successful steamboat was Robert Fulton's North River steamboat, often incorrectly called the Clermont, in 1807, which operated on the Hudson River in New York. By the mid-19th century, steam-powered ships were crossing oceans, dramatically reducing travel times and transforming global trade. The steam engine had truly become the driving force of the industrial world, its influence extending into every aspect of life and commerce. As we approach the end of the 19th century and move into the 20th, we see the steam engine evolve once again with the development of the steam turbine. Invented by Sir Charles Parsons in 1884, the steam turbine offered greater efficiency and power output than reciprocating steam engines. This technology quickly found applications in electricity generation and marine propulsion, areas where it remains important to this day. Indeed, while we may not think of it often, steam turbines driven by nuclear fission or the burning of fossil fuels still generate the majority of the world's electricity. However, the dominance of the steam engine in its traditional forms began to wane in the early 20th century. The development of internal combustion engines and electric motors provided alternatives that were often more suitable for many applications. Diesel locomotives began to replace steam on the railways, while petrol and diesel engines took over road transportation. In factories, electric motors offered more flexibility and cleanliness than steam engines. Despite this decline in many areas, the principles developed during the age of steam continue to be applied in modern engineering. The steam engine may be seen as the exemplar of the Industrial Revolution, but its principles live on in the turbines that generate much of our power today. The age of steam has not ended. It has merely been transformed. The legacy of the steam engine extends far beyond the realm of technology. It played a crucial role in shaping the modern world, driving industrialization, urbanization, and globalization. The steam engine changed not just how we work, but how we live, travel, and interact with the world around us. Its development spurred advancements in thermodynamics, materials science, and mechanical engineering. The story of the steam engine is, in many ways, the story of the modern world, a tale of innovation, progress, and transformation. As we face new challenges in energy and technology today, the history of the steam engine serves as a powerful reminder of humanity's capacity for innovation and the profound impact that technological advancements can have on society. And with that, we come to the end of our journey through the history of the steam engine. I hope this exploration has given you a deeper appreciation for this remarkable technology and its impact on our world. The story of the steam engine is a testament to human ingenuity and the power of continuous innovation. It's a reminder that even the most transformative technologies often evolve gradually, building on the work of countless individuals over many years. As we look to the future and the challenges we face, particularly in terms of energy and climate, perhaps we can draw inspiration from the inventiveness and perseverance that characterize the age of steam. Thank you for joining me on this journey through time and technology. If you've enjoyed this video and would like to see more content like this, please consider liking, subscribing, and sharing your thoughts in the comments. Your support truly does make a difference and helps shape the future content of this channel. Until next time, keep your curiosity stoked and your mind open to the wonders of science and technology.